Okay, so those are your questions for today. If you think you know the answer to any of those questions, you can head over to some of our social media on Instagram, Facebook, and elsewhere to go ahead and post your answers to those questions. But let's go ahead. We're going to jump now into our next segment, which is our engineering tribute. So I hope you're excited and ready. We're going to dive right in. There's going to be no break here. We're going to go right into it. Okie doke. So I hope you're ready. I hope you're excited. Now, for those of you who don't know, the engineering tribute is a segment of the show where we get to highlight some of the work done by an engineer or researcher. And today we're taking a look at Rabab Ward. So we're going to take a look at some of the things that she's done to better society as a whole. So first things first. Rabab is a professor at UBC, and she's a Canadian professor, right? We can kind of tell by her plaid jacket, very Canadian, right? She raised the importance of engineering and particularly women in STEM. So she is a big advocate of women and girls in STEM, which is always great to see. And she's a member of a variety of different institutions. So we've got the Canadian Academy of Engineering, the Engineering Institute of Canada, and of course IEEE. She was actually the first woman to be appointed as a professor in British Columbia. So that is pretty cool as well. And she is, again, a fellow of all these different societies. It's very important to be involved in your community if you're trying to make a big impact, right? The best way to get to know some of the issues that you can work on and help out with is to be a part of these societies, be a part of these communities and these clubs, and talk to people and find out what are those problems that you can help solve, right? So that is some of what Rabab has done. Cool little side note, you'll notice in the IEEE that there is a little electron, or there's like an arrow pointing up and then a little arrow pointing around. That is actually to show the connection between the electric and magnetic fields. And you can actually see that with our drawing here in the bottom left hand. That's the right hand rule. So if you're studying engineering at all and you're learning the basics of electrical engineering, you're probably going to learn the right hand rule. Very useful. Okay, so a little bit about Rabab and some of the work that she focused on. A lot of her focus was actually on signal imaging and video processing. So working with different kinds of electrical signals, both digital and analog, and trying to make them the best that they can be for images and video processing in particular. So there's a number of aspects to her research, including signal detection, image encoding, compression, recognition, and restoration enhancement. So typically when you're sending a message across a line or so, you'll want to compress it to be as small as possible, right? And we can do that by recognizing patterns in the code that we can represent by a smaller symbol. And then when it gets to its destination location, right, then we can convert it back into the more lengthy, redundant original code that it needs to be to, say, light up a bunch of LEDs. So very cool. So again, thank you, Rabab Ward, for all that you've done in terms of women in STEM, your completed work that is going into that, and of course the research that you've done into signal processing and imaging. Very, very cool. So let's go ahead now. We are going to transition into our Maker Highlights. Now this is a segment of the show where we get to highlight some of the very cool projects that have been worked on either by students here at Zen or submitted to us for a Maker Highlight. And today we've got two special projects to share with you. We've got a Liam's Sattelite, and we've got Max and Leo's Build, which is a very cool structure. So we're gonna see both of those right now. Let's go ahead, let's jump into it. So first up, we have Liam's Sattelite, and this one's pretty cool. We can see that we've got our two side panels there on our satellite, and those panels are typically solar panels. So if you've seen a real satellite, right, they typically have these big panels on the side, And that's because there is no AC outlet that we can plug this satellite into, right? If you're floating out in space and your phone dies, how are you going to charge your phone, right? That's a serious issue. Well, on basically every satellite, there will be some way to charge it using solar power, right? So once these satellites get into space, they normally are attached with these big solar panels that allow them to recharge or get power, right? So we can see that here. So he's included that. That's pretty good. We've also got, of course, a little dish on the back, or not a dish. Maybe that's a dish, actually. It could be a dish. Maybe it's the jetpack. I'm not sure. Maybe you can let us know, Liam, a little bit later. But yeah, so it could be a jetpack, which makes sense, right? We want to be able to maybe move and tilt this satellite around, but more likely it's a dish, right? So that we can actually send signals back down to the Earth in a more directed way. That's typically why you use a dish, right? So when you're sending if you're sending out a radio signal on an antenna, right, it's normally going to disperse in all directions, okay? It's going to go out, radiate in all directions equally. But if you put a dish behind it, it will kind of construct the waves. The waves will bounce off of the dish and head out in the direction that the dish is pointing out to, right? So that's what that dish does, right? Is it directs those waves rather than going out into space. It tries to direct them towards the Earth. So again, very cool project, Leah. Good job. And so next up we have Max and Leo's build. So let's go ahead and take a look at this cool jungle gym. I thought that they did a really good job. I can see that there was a lot of different parts and steps that went into building this design, and it was a collaborative design. So that's always very cool to see. So let's go ahead, let's take a look at this build. Okay, so we're right into it. So we can see here there are a couple different components to this build. We've got some stairs here, and it looks like this entire build, this entire house and jungle gym was actually made out of basic shapes, which is really impressive, right? So we can see here that we've got a whole bunch of stairs, and it looks like these stairs have been actually placed manually, so that would have taken a lot of time. So good job on you guys for doing that. One thing that I would recommend if you're working on those stairs next time is rather than doing it manually, you've probably heard me say this before, but the duplication tool is so cool. You guys should be using it. Use the duplication tool, guys. It's very, very useful. So we can see, guys and gals, we can see here if I just duplicate, look at that. That was so easy, no effort at all, right? So, very cool. Ooh. But very cool, well done. A lot of effort that went into those stairs, and they look pretty rad. We can see that the pillars here are actually just cylinders that have been stacked on top of each other, which is pretty cool. And that's how we made those things. Rather than stacking these cylinders, again, what these guys could do is once you've got your platform up at the height that you want, you could just extend a cylinder up to it. So just to show you what I mean, if I get a cylinder like this, okay, and I want it to extend, or I want to hold up this plate, rather than just like duplicating it and putting another one on top, you can actually just stretch this all the way up. And it gives it a little bit of a cleaner look, and it'll print easier, right? It'll print easier because there are less objects that need to be considered when we're building out the model. So very cool, the pillars here. And I like that this thing's got like 2 floors. So you get up there and it's not like, oh, you're done. No, you can go up here and then you go down here. It's it feels a little bit like, what is it? There's a Go Bananas, right, at Park in Tilford. Yeah, so it feels a little bit like Go Bananas, where you're running up and down this giant jumble gym. We've also got here a seesaw, which is pretty cool. Everybody likes to play around on a seesaw. And then it looks like maybe we've got some cool houses here, or maybe this is like an obstacle course where you're supposed to try and climb up this thing. And again, these guys can actually just be rather than stacking all these on top of each other, we could do something like this. Ooh. And we could even use the duplication tool just like that, just like you saw. Just moving this over and then bringing this piece down a little bit. And then we could even duplicate it again. And there we go, right? We could have done something like that. Saves us a little bit of time. What else do we have going on here? I thought this was pretty cool, this piece of artwork here that these two did. Look at this. We are balancing something that looks like it should fall over on top of this little point, right? So it's very cool. We know that this probably wouldn't be a balanced system if these two parts weren't attached by some sort of bolt or glue, right? But how do we know that? Why do we know that this is going to kind of fall over? Well, it has to do partially with torque. So we already have sort of an understanding of how things will balance and the forces that are acting on some big piece like this, right? So if the force on all the sides here is not equal, right? If the mass is kind of slanted like it is here, then there's going to be more force on this side. And so the part should sort of accelerate and sort of fall over, right? But that's why these designs are very cool. There's some really cool physics breaking designs that you can see with tensegrity. Recommend that you check those out. Those designs are really, really cool, especially the statues and things that look like they're holding tables up by chains. It's very, very cool. But good job, Max and Leo, with your build. So that concludes our Maker highlights for today. I hope that you enjoyed. If you would like to see your Maker highlight, you or your class, up here on the big screen, you can send it to us through our website. If you head over to our contacts page. And yeah, we really encourage that. We think that we want makers from around the world. We want to be able to share all your designs and the cool things that you're working on. But thanks so much for checking out the Maker highlights. Don't go anywhere, because up next we have an interview. We have an interview with a special guest, Stephen Kitchen, a freelance designer and illustrator.